Hey everyone, in this tutorial we will learn how to take a MERN application, so an app that's built with React and Express, and put it on a real web hosting, so that we can reach it over the internet rather than just over localhost like we do in development all the time. We will also take care of the necessary security settings and best practices so that our server is less likely to get hacked later, and we will even connect everything to a real domain and set up an SSL certificate. For this we will use the MERN application that we built in my MERN beginner tutorial over on my channel, Coding in Flow. But if you have a different Express app that you want to deploy, then of course you can also follow along, it all works the same. And I will also prepare a GitHub gist file with all the commands that we use in this video, so you can copy paste them from there if you don't want to type them out. We will put a link to this gist file into video description below, and then we are ready to start. Okay, and we will deploy everything to Linode, so go to your Linode backend. If you don't have an account yet, sign up for one, and then log in. And then here in the sidebar we go to Linodes and click on Create Linode, which creates a server. Now we have to select a few things. First of all, the version of Linux that we want to use. For our server we can keep the default setting, Debian 11. Then we have to select a region for our server. And it makes sense to select a region that's close to the majority of your users or where your database resides, so that the connection speed is faster. I'm in Germany, so I'm gonna pick Frankfurt, but you can use whatever makes sense. Alright, and then we have to choose a Linode plan. Here it's up to you what you need and how big your website is, but generally for smaller projects the shared CPUs are enough. And I'm gonna pick the cheapest one just for this tutorial, but you might wanna pick something higher. It depends on what you need, and you can also upgrade later. So I'm gonna pick Nanode 1 GB. Then we scroll down further. We can give this a label, so a name basically. Gonna call this Coding in Flow MERN tutorial. We can add text to it, which is just a way to organize your different servers. We don't need this. And we have to set a root password. This is the password we then use to access our server, at least for the first time. We will later disable root and also passwords because it's safer to not have this while the server is running. But the first time we log into our server we will need this. So go ahead and set a password here. We ignore the SSH keys for now. We will actually use that later, but we will set it up directly on the command line. So we can skip this part, we can also ignore this. You can decide if you want any of these add-ons here, like backups. I'm not gonna pick any of them because it's just a tutorial project and I will delete it later, but you might want to have backups or private IP. Alright, and then we click on Create Linode. Then we have to wait a short moment until our server is finished booting. And then when it says running, we are ready to go into our server. Oh, that's very exciting. So we need this part here, the SSH root. So when we click on this, we copy it, and then we want to open the command line on our PC. So on Windows this thing is called PowerShell, but Linux and Mac of course also have a command line. So go ahead and open it, and then we want to paste this root login command we just copied, and we can paste it by right clicking. So this way we can log into our server under this root account here. And this is the IP address of our server. It's a unique identifier. This is where we can also later access our server on the internet until we have a real domain set up. So we press enter, and when you do it for the first time there's always this warning, so we confirm this by typing in yes and pressing enter. And then we have to type in our root password we just set up on Linode a moment ago. And then we are inside our server. As you can see, the text down here in front of the colon changed from the user on my Windows PC to root at localhost, because we are now inside this Linux server. And every command we execute now will be executed inside this machine, not on our own PC. Okay, and the first thing we want to do is we want to check if there are any updates on the server that we have to install. So we run the command apt update, which updates the information about the packages that are available basically. We wait until this is finished, all packages are up to date. And then we run apt upgrade, not update, but upgrade this time. But I think this shouldn't do anything because everything is up to date already. Yeah, it hasn't updated anything. But it's good to do this regularly to keep your server up to date and install the latest security patches. So you should do this from time to time. There's also a way to set up automatic updates, but you don't always want this. So before you set this up, you have to read into it and the downsides it has because it can break things. If you want to learn more about this, just Google for unattended upgrades. But here we won't install this. Then we want to set up a new user account here on this server and get rid of the root user we just used to log in. It's generally recommended to disable root because it's an administrator account basically. It has all the rights on the server. It's much easier for us to do damage if we are always logged in as root. And also the applications we run as root have too many privileges. It also makes it a little bit easier for hackers to brute force our login credentials. Because there's always a root login by default. So this is what hackers will try first when they try to crack our password. So by setting up a different username, we also make this a little bit less likely because they have to guess our username first. But the most important part are the privileges that we want to avoid from this root account. So what we do is, in the command line we type in @user like this, and then the username. Gonna use my name Florian, you can use your name. Now we have to give this user account a password. I have to retype it, and you will need this password a lot later, so you have to remember it. And then we can set up some metadata here, like the full name. You can set this up, you can also skip this. Just gonna type in the name and skip the rest. Is the information correct? We type in a Y for yes, and our new user is set up. Now this new user doesn't have these administrator privileges like root has, but sometimes we need these privileges to execute certain commands. So we have to add our user to a special group, which allows it to use a command called sudo. You might have heard of this already before. Sudo allows us to temporarily have these root privileges, but not all the time. That's the important difference. So what we do is we type in usermod, and whenever we type in commands in the command line, it's important that you don't have any typos in there, because otherwise it will not work. The command line is not very forgiving. So usermod, all lowercase, -a in lowercase, then in uppercase G, which means add group. So we add the user to a group, and we want to add it to the sudo group, and then the username, Florian, or your username. So this is the full command. We press enter, and now this user should have sudo privileges. So what we do now is we log out with root by just typing in logout and press enter, and then we want to log in with our new user account. So by pressing the up button, we should get the last command again, or just type it in again, but we replace root for our username. And now this wants to have our password we just set up. And now we are inside our server, but this time not as root, but as Florian. We can check if this worked by typing in sudo -v, which is just a command to extend the current login session, so it's harmless. And then the first time we do this, we get this little warning here, which basically tells us to not mess anything up. But this shows us that sudo is working, because if it didn't, we would get an error message here that this command is not recognized. So now we can type in our password and we are good to go. As I already hinted at, we will later completely remove the root login. At the moment it still works, but we will disable this completely. We will also disable password login. So the last time we logged in as Florian, we had to type in our password, but passwords are not really that secure, for one because they are sent to the server, but also because people just tend to write bad passwords. So a better practice is to use SSH keys instead. And they work in a way that we have a public key on the server and a private key on our local machine that we use to log in. And then we can basically only log in from this machine that has this key. And this key is very large, it's impossible to guess, and it's also not sent to the server. So the first step is to create a folder where we put this public key. For this we type in mkdir, which stands for make directory if I'm not mistaken. It creates a new folder. Then this quickly line /.ssh, and then we type in 2 ampersand signs because this appends another command, chmod like this, 700, and then again the same squiggly line /.ssh, and this chmod command sets some necessary access permissions that we need for this user to access this folder. So we type in exactly like that and press enter. And when we type in ls, we can see the folders and files on the current place where we are in. Okay, we don't see anything because it doesn't show hidden ones by default, but we can show them with ls-a. And now we can see that we have this SSH folder we just created a moment ago. Next we want to log out again. because we want to get back to our computer, because now we have to generate this private key that we use to connect to our server. So we type in SSH minus keygen like this, then this B flag, which stands for bits, I think, and then 4096, which is basically the size of this key, and the bigger this is, the more secure it is, basically, and this is a good value to use. So we press enter, and as you can see, it generates a public-private RSA key pair. We have to select the location where we want to save this. I'm going to choose the default location here. So by default, it's under our user account, and then this .ssh folder id_rsa. You can also rename this if you want, but I'm going to confirm this with enter. And then we can set a passphrase if we want, which is just another password for this key. So if someone steals our computer, especially if you have a laptop, then they could use the key on your device to log into your server, right? So another security measure is to also add a password to this key. So I'm going to set one here. We have to repeat it. And then we get this random art image. We don't need this. We don't have to remember this. We don't have to do anything with it. If you want to learn why we get this and what's the purpose of this, you can Google it. And if everything went correctly, you should now have this folder here on your computer and these files with the keys. This is the private key. This is the public key. This is the known host files where we added our IP address to at the very beginning. So now what we want to do is we want to push this public key to our server, because this is where it belongs, and the private key stays on our machine. So let's go back into the command line. We are still on Windows, not inside our server. And now we have to type in a command that pushes this public key to the server. And this command is different depending on your operating system. I will show you all of them. Let's start with Windows. So we type SCP $env : then user profile in all uppercase like this. /.ssh /id_rsa.pub. And again, I have a gist file in the description below where you can copy paste this from, but I think the first time it makes sense to type this out by hand, just so you get a feeling for the single parts that belong to these commands. Then we type in a space, and then our login credentials for the server. So the username, then the server IP. I can see it up here. That's the one we used earlier to log in. This will be different for you. For me, it's 143.42.27.6. Then again a colon. Then another squiggly line. /.ssh /authorized_keys. So this is a long command, but this just puts the public key from our PC onto our server into this folder. Pretty straightforward. Then we press enter. We have to type in our password again. And now we see that it uploaded this key to the server. Okay, now I'm also going to show you the commands for Linux and Mac. So for Mac, it's almost the same as the Windows command, just that we replace this env user profile for another squiggly line. So like this. And on Linux, we just want to keep our Florian @ and the IP address. So we remove this part. We remove the part in front of it. And then the command is simply ssh -copy -id. And then the username, @ and the IP address. Alright, then we want to log in into our server again. So ssh Florian @ IP. Now it doesn't want our password anymore, it wants the passphrase of our private key on the PC. So we type in the passphrase we set up. If you haven't set up a passphrase, it will just log in automatically. Just be aware that this is less secure if someone steals your computer. Next, we want to change some more settings in our SSH configuration, because it's still not really secure yet. So we type in sudo, because we need elevated rights in order to execute this command. You can also try what happens if you skip the sudo, then it shouldn't work. Nano, which is a text editor here on Linux, so we can use this to make changes to a file. There are also different ones like Vim, but that's for power nerds because it's impossible to use. We're going to use Nano, which is pretty simple. And then the file we want to make changes to. And we type in /etc/sshd_config, which is this config file that we want to change. So we press enter, add our password because we use the sudo command. And then it should look like this. We are now inside this sshd config file. Here we want to make some changes. And these pound symbols here, or hashtags for your young people out there, are comments. So everything where there is a hashtag in front of it is not active at the moment. If we want to activate it and make changes to it, we have to remove the hashtag symbol here. The first thing we want to change is the port. 22 is the default SSH port, which we use when we log into our server. Now it can make sense to change this because everyone knows that this is the default port, so it's a bit easier to guess. And by changing this to a different port, a hacker doesn't only have to guess our username and needs our private key, they also have to figure out the correct port. Now there are different opinions on how useful this actually is, but I think it makes sense. So we set this to a different port and you can basically pick any number here. The highest number we can pick is somewhere in the 65,000 range, but I read that it's actually good for security to pick a number below 1024. Now there are also certain ports that are reserved already, which you shouldn't use, otherwise the server could malfunction. But I will put a list with these reserved ports into the gist as well, so you can take a look at it. I'm gonna pick 16, which should be free. Next we want to go below and remove the comment from address family and change this from any to inet. This disables IPv6. There are two different kinds of IP addresses. IPv4, which is this one we use to log in, and this one here is the IPv6 address. IPv6 on our server at the moment isn't really used for anything, so it's good to disable it because it's another attack vector that we don't have to worry about. So this way we only use IPv4. Then we scroll down to permit root login and change the yes to a no. As the name implies, after changing this we cannot log in as root anymore, which as I explained earlier is not secure. So we disable this. And we also disable password authentication, which is down here. Password authentication, we change the yes to a no as well. This way we can only log in using our public private key pair and not the password anymore, which again is more secure. Alright, and that's all the changes we have to do in here. To save this with nano we press Ctrl X. As you can see down here, that's the command to exit, Ctrl X. Then we type in a Y to save the changes and confirm it with enter. And now the changes to this file should be saved. But we also have to restart SSH before this comes into effect. So we type in sudo systemctl restart sshd. Enter, type in our sudo password, and now our changes should be in effect. So let's try it out. Let's log out again. First let's try logging in as root, which should be disabled by now. So nothing is happening. Connection refused. Now let's also try logging in with our Florian account, which shouldn't work either because we changed the SSH port. So again, connection refused. Let's use this command again, but this time use our port 16. And we do this by adding a -p behind it and then the port number 16. Okay, and now it's asking for our key passphrase again. And we get into our server. So this port change just makes it a bit less likely that someone brute forces our login credentials because hackers usually scan for 22, the default SSH port, and root login is completely disabled now. Okay, and next we want to install a firewall, which basically protects all the available ports, and we have to manually enable all the ports where we want to allow access to, which is just more secure. So we install the firewall with sudo apt install UFW. UFW stands for Uncomplicated Firewall. That's a really nice name. We install this, need our sudo password again. We confirm this with yes, with a Y, and wait until the installation is finished. Alright, after the installation succeeded, we type in sudo UFW status, which should show inactive, because we have to activate it first. But before we do that, we want to allow certain ports that we want to make access to, like our port 16 for SSH. So we type in sudo UFW allow 16. So now it added this rule so that we can access our server on port 16. And then we also do sudo allow HTTP, which is port 80, and HTTPS, which is port, I think, 443. We need this so that we can later actually access our website under these ports. Otherwise, when we type in the address in the browser, we won't get through the firewall. Alright, and then we type in sudo ufw enable to enable the firewall. And now it gives us this warning because if we did the setup incorrectly, we could log ourselves out of our server. We confirm this with a Y. And if you ever log yourself out of your server, then you can always go back into your Linode backend here, log in with your normal account, and you can reset the server, you can reset SSH access and everything in here. So there's always a way to get back into your server, or at least reset it. Alright, and now if we type in sudo ufw status again, we should see this. Those are the allowed ports right now. Next, it's considered a good security practice to disable pings, because pings allows us, but also other people, to see if our server is online under this address. And if people know that it's online, then they have a target to try to hack. So here I've opened another terminal. You don't have to do this, I just wanna show you the ping in action. So still in Windows, I type in ping and then the IP address of the server, which again is this one here. Let's copy this. And then I think the command was T to keep it pinging, so it doesn't stop automatically. As you can see, it pings our server and it always gets a response. And again, it's a good idea to disable this. So I'm gonna stop this for now. Go back into the other terminal where we are still in our server. And we type in sudo nano to make changes to a file, /etc/ufw/before.roles. Alright, and then we get into this file. Okay, and then we want to go down to this block here where it says input and add another line at the top. The beginning is the same as the line below it. Minus uppercase E, ufw minus before minus input minus p, icmp minus minus, icmp minus type. And from here on it's different. Echo minus request, space minus lowercase j, space and then all uppercase drop, which disables the ping. So we save this with Ctrl X, confirm it with Y and enter. Now we have to reboot our server, which we do with sudo reboot. This will take a moment and we get kicked out of SSH because the server is restarting. So now we have to wait like a minute or two, maybe 3 minutes, and then we can go on. And as long as the server isn't back up yet, we will not be able to log in. So this is how you can figure out when the server is actually back. As you can see here, it's not responding, it's timing out. As soon as the server is back up, this will work again. So if we wait a bit, this will show a timeout message. There it is. We just try it again in a minute or so, and then it will work again. Alright, let's try logging in again. And it works again. We need our passphrase. And we are back in our server. The difference now should be that we can't ping our server anymore. So this should time out as well. And it looks like it does. Yeah, it did. So pings are now disabled and our server is a little bit more secure. Alright, now it's time to actually install our code here, our Express and React app, and get this running, because what we have done so far are only security measures. So first we need to install Node on this server here. Even if it's already installed on your local machine, it's not installed on the server yet. First of all, we need a command for that, and we get it from this URL. Again, I will put a link to this into the gist. We want to install Node.js 18, because that's the current LTS version, the long-term support version. 19 is newer, but doesn't get these long-term updates like 18 does. So we want to copy this command here first. We copy it all the way until here without the 2 ampersand signs, because the 2 ampersand signs are only there to put these 2 commands into the same line and execute them all at once. But when I tried this, it didn't work properly. So I copy this part here before the ampersand sign, paste it into our terminal on the server, sudo password. And this basically just fetches the information about this package so we can install it with the next command, which is this part here. Paste this in as well, execute it, and this installs Node.js on the server. Okay, after this is done, we can check if Node was installed successfully by typing in node ---- version. And it should say something. In my case, that's 18.13. And the same should now also work for npm, the node package manager. This should also show a version. I just realized that I copied the Ubuntu command and not Debian, what we are using, but it should actually not make a difference. And we also need the sudo because we are not logged in as root. So if you copy this command here, it should work. If you copy the command down here, you have to add a sudo before bash and before apt-get install. But again, using these commands up here should work because there's already the sudo in it. Alright, next we also want to install Git, which we need to fetch our code from GitHub. So in the command line, we type in sudo apt install git, confirm it with y. Again, we can check if it installed successfully with -- version. Yeah, git version is installed. And now we want to make a folder where we put our code in, just for organization. So what many people do is they create this apps folder with mkdir apps. Now when we type in ls, we see this apps folder. We can go in it with cd apps. So cd stands for change directory. So now we are inside this apps folder. And here we want to clone our code into. And cloning your repository from GitHub is just a nice way to get your code onto your server, because you don't have to transfer any files from your local PC. You can just fetch it from the internet with a simple command. And for this example, we will use the code from my MERN course here, which is in this public repository. This is a public repository, so we can just clone it without having to log in. If it's a private repository, you will have to set up a personal access token, which you can do in your account settings on GitHub. So here on this drop down, you can go to settings. Then you can scroll down to developer settings and set up a personal access token here. Usually it's still using the classic one. So you have to create such an access token that can read from your GitHub account. And then in the command line, it will ask you to log in with this token. But again, we don't need this because this is a public repository. So we go into our apps folder on our Linux server. And then we type in git clone and paste the URL of this repository that we want to clone. And press enter. So this was very fast. When we type in ls, we can see in this very hard to read blue that there is now our MERN course folder here. So let's go into there. And by the way, you can autocomplete this by pressing the tab key. If there's only one folder, then it will use that name. Otherwise, you can also type in the first few letters and then press tab. ls again, and there's our backend and our frontend folder and this readme file. It's now on our server. Now our backend code requires some environment variables to work, like the connection string to MongoDB. We have set up all of this in my MERN course. If you're using your own code, you might not have to do this, but if you use my code here, then we have to set up these env variables properly. So we cd into the backend folder. And when we type in ls, we see that there's no env file in here, and ls-a will also not show a .env file. Because this is included in gitignore. We don't want to push this to our server because this can contain sensitive data. Instead, we have to create a new env file here from within our server. And again, we do this with the nano editor. So we type in nano.env, which creates this new env file. So the variables we need in here are our Mongo connection string, written like this in all uppercase with underscores. Mongo connection string equals. We need our session secret for our cookie, and we need a port that the server should run on. We set the port to 5000 again, like in the tutorial, and the session secret can be any arbitrary string. Doesn't matter. But the Mongo connection string we get out of MongoDB Atlas. If you followed my tutorial, then all of this is already set up. If you didn't follow the tutorial but you still want to deploy my app, you have to create an account on MongoDB Atlas. You have to create a new cluster with M0, which is the free tier. And then you have to set up a user here that can access the database. And this user has a password, which we have to use with a string that we use to connect to our database. So when we click on database, we can click on connect. And here on connect your application, we find this string. This is what goes into our env file. So we copy this. Paste it after Mongo connection string. But then we have to replace this password here after Florian colon, or whatever your username is, for the password you set up for your MongoDB Atlas user. In my case, that's this password. Of course, you should keep it a secret. I just show this because this is not a production database. Okay, and the same as in the tutorial, we can also go behind mongodb.net. This is not necessary, but here we can change the name of our database where we store our stuff in, our documents, because by default this is called test. In my tutorial we call this cool_nodes_app, and I want to keep the same name, so I add this here. Okay, and when we have entered all of this, we can save this file. Control X, Y, Enter. And when we type in ls-a again, we can see our end file here with our env variables in it. So the next step is to install all the dependencies of our front-end and back-end code, because again the node modules folder that contains all the code of the packages that we install is also not pushed to GitHub, because it's huge and it's not necessary. All the information about the packages and the versions we use is inside this package.json file here, and then in our server, while still being in the back-end folder, we can just type in npm install, and it will install all these packages again and recreate this node modules folder that we also have on our machine when we run this on localhost. So we wait until this is finished. Yeah, new major version of npm available. It always makes sense to install this. So we type in this command here, npm install -g, which stands for global, npm add 9.3.1. Install this as well. Okay, we get an error because we have to install this as sudo, because it's a global installation and we need these elevated rights. Sudo password, and now this should work. Okay, nice. Let's try ls-a again. And there's our node modules folder here with all the dependencies. Now we have to do the same for the front end as well. So we type in cd and 2 dots, which gets us back one folder into the Mern-Course folder, and we cd into the front end. And here we do the same, npm install. Install all these packages, wait until this is finished. Alright, and then we have to build our React code, because before you can deploy it, you have to build it, which does some stuff like optimizing the code, minifying the code, and some other things. And we do this inside our front-end folder with npm run build, which builds our React code so we can actually deploy it. Creating an optimized production build takes a few seconds. And by the way, this also transpiles the TypeScript code automatically. This is taken care of for us by this build script. Alright, and when this is finished, it should look like this. Now we also have to transpile our backend code from TypeScript to JavaScript, because TypeScript itself can't run, JavaScript can run. Again, in our front end, this happens automatically with this build command. In the back end, we don't have such a build command. Instead, we use the TypeScript compiler to turn the TypeScript code into JS code. So we go back one folder, cd into the backend, and now we first have to install TypeScript, also globally. So we type in sudo npm install -g, the global flag, and the name of the package is TypeScript. This allows us to use the TypeScript compiler anywhere on the server. Okay, and then still inside the backend folder, we just type in tsc, which transpiles the TypeScript code into JavaScript code. So again, this takes a moment. And after this is finished, we can type in ls again, and we should see this dist folder here. Dist is where TypeScript puts our compiled JavaScript code. So let's actually take a look in there. cd dist, and we can see that we have server.js in here and app.js. Our own code was app.ts and server.ts because we wrote it in TypeScript, but this is the compiled JavaScript code. But we don't have to do anything in there, so let's go back into the backend folder. The next step is to go back into MongoDB Atlas and allow the IP address of our server to access our database. So we go to network access, and this is currently just the local IP of my machine. I want to add another IP address, the one of the server, which you can copy from Linode. That's also the one we use to log in with SSH. Can confirm this, and then it takes a few seconds to activate this. Alright, and when that's done, let's go back into the command line. Now I actually want to start the server so we can see it running. Now this is not the whole story yet, we still have to add some other software on the server to run the server properly even when we close the terminal. But just for presentation, I quickly want to show you that this already works. But our server is running on port 5000, right? That's what we have set up in the end file. Port 5000 is currently not in our firewall, so we won't be able to access the website under this port. So what we do is just for a moment disable the firewall. You don't have to do this because this is just for me to show you how we can access this website under the IP and this port right now. But it's important that we later activate this firewall again. So just for presentation, I'm going to type in sudo disable UFW. That was wrong. The command is actually sudo UFW disable in this order. And we have to reboot the server. Again, you don't have to do this. You can also just keep it enabled and just watch me do it. So I'm going to reboot the server and wait until I can log in again. Okay, so I've waited a bit. Now I should be able to log into the server again. Okay, so I want to go into the apps folder, into the MERN folder, into the backend folder, and I want to run this. So we have already compiled the code with TypeScript. Now we can run it with the node command. So we want to go into the dist folder and run server.js. And now we should see a log message that says, yeah, server running on port 5000, Mongoose connected, which are the logs that we have set up in our code. And now we can actually go to the address of our IP address and then a colon and the port we run our server on. And we get this endpoint not found error message back, but this shows us that our server is running because this is the server message we have set up in our server. And you can also see here in the logs that someone, us, tried to access this endpoint. We can also try something like /API/nodes, but we won't be able to access this because we are not authenticated right now. But this shows you that our server is running under this IP address. And this is now available to everyone on the internet. Not only we on our local machine, everyone can go to this address and access the server right now. But of course we want to put this on a real domain, so we are not done yet. And we also want to not have to keep this command line running right now, right? Because if we stop this with Ctrl+Z, then this address is not available anymore. So we need something that keeps this server running even if we close the terminal, even if our PC is off. This is what you want to use a process manager for. And a popular one is PM2, which we can install with this command. This runs our server even if we close the command line. It also does stuff like automatically restarting it after rebooting the server, which is important. Has some other features, monitoring and so on. You can read more about this under this URL if you want, but we need this command here. So we copy this and install this on our server. But this will probably only work with sudo rights because it's a global dependency. Yeah, so we have to type this in again, but this time prepend sudo in front of it. Password and install this. So now we want to start our server.js file again, but this time using PM2. So we type in this PM2 command, start, and then again dist/server.js. Now this looks a bit different. We can see that our server is online. We can actually reach the address again. But now our terminal is free. We don't have to keep this running. We can even completely log out and close the command line. And when we refresh this, the server is still running. But we are not done yet. So let's open another terminal and log in. I want to show you a few useful PM2 commands that you might need. So first of all, PM2 status allows you to see this chart here again if your server is online and what kind of processes you have running. There's also PM2 logs, which we can now use to see the log messages from our server. So when I refresh this, there should be another entry in the logs because this is live. Yeah, we can see that someone tried to access this endpoint. We can get out of this with Ctrl+Z. PM2 flush clears the server logs. So now when we show the logs again, this is empty. And then there's also PM2 restart server, which as the name implies, restarts the server. And server this time refers to this name here. So we don't type in dist/server.js, instead just server, which automatically picks this one here because this is the name of this process. This restarts the server, for example, when you make a change to the code. So you don't have to reboot the whole server. And you don't have to run the node command, instead you restart the server over PM2. Of course, you can read more about these different commands in the PM2 documentation on its website. What we also want to do is setting up a startup script so that when our server reboots, PM2 will automatically restart our server. Otherwise, we have to do this manually, and this can cause situations where your server reboots for whatever reason, maybe for maintenance from your hosting provider, and then your website is not running again because PM2 didn't automatically restart it. But we can configure this by typing in PM2 startup, enter, and then as it says, we have to copy paste the following command, this one here. So we can select this, press Ctrl Z, and paste it with a right click, and then execute this. Sudo password, and this sets up the startup command. So let's actually try this out. Let's type in sudo reboot to reboot the whole server. While the server is down, our website will not be available, but as soon as the server is back up, PM2 will automatically restart our server without us having to do this manually. So we don't even have to log in, we just have to wait and this website will be available again. Okay, so I've waited a bit, I haven't logged into the server again, but our website should be available, and it is. Really nice. So let's go back into our server as well. First of all, let's enable the firewall again, that's important. This also means that our website here will not be available anymore because it's running on port 5000, but we will then install a software on the server that forwards this port 5000 to port 80 or port 443, so HTTP or HTTPS, that we already allow in the firewall. So what we do is sudo ufw enable. Password, disrupt, yes, that's okay. And we have to reboot our server again. If you didn't disable the firewall earlier, then you don't have to do this. But this also means that your website was probably not available under port 5000. So again, I have to wait a moment until I can get back into my server. So then I SSH back into the server, passphrase, and then we want to install Nginx, which is this software here. It's an advanced load balancer, web server, and reverse proxy. Those are some very fancy terms, but it's something that's running between your node server and whoever accesses the server through the website. And Nginx has many different features. For example, it can balance the load between multiple server instances if you want to have multiple servers running. It also has some security benefits when it's running in front of the server, and it also allows us to serve the React frontend and our Express backend on the same URL. All these features and more are possible through Nginx, and we can install it for free on our server. So, back into command line. After logging into our server, we type in sudo apt install nginx, which is spelled like this. Sudo password, confirm this, and wait until the installation is finished. That was fast. Now we just have to do a little bit of configuration before this works, but that's not a lot. We type in sudo nano /etc /nginx /sites -available /default. That's the file we want to make changes to. And when we press enter, we get in here. Okay, so we want to scroll down into the server block. We keep this listen 80 and everything. 80 again means HTTP. And then we want to change this root here. We want to point this to the build folder where our compiled React code is in, because this way we can run it when someone accesses the website through the URL. This has to point to the place where you put the MERN folder. In our case that's home, because home is where the user accounts are in. Then our username, in my case Florian. And then we created this apps folder, remember? Then inside the apps folder there is the MERN-course folder, that's the name that the repository had on GitHub. And this is also the name of the folder, /frontend, and then /build, where the compiled JavaScript code is in. We add this as the root. Then we want to set the server name down here to the URL that we will later use to access our website. The URL is something you have to buy. I will show you later how this works. And for this tutorial, I've bought the URL that has this address, codingandflow-sample.com. And then we also have to enter the www version after a space. So again, www codingandflow-sample.com. Again, you have to type in whatever address you want to use for your website. Okay, and then under location, we can say what we want to serve through our server on our different URL endpoints. This says location / which is the root URL. So codingandflowsample.com with nothing behind it. Here we want to go down here, but make changes to this. So we want to keep try_files and $URI, but pass /index.html. So this will serve the index.html file in our root folder, which is here inside this build folder. And if you watched my MERN course, then you know that index.html is where our React app runs in. So by serving this file, we serve our React app under the root URL. We can also delete these comments here because they don't fit anymore now that we have changed this. And this is the part that runs our front end. Now we also have to set up a location block for our backend. And I'm gonna paste this in. You can copy this from the gist in the description, or you can also type it out by hand if you want. But I also want to align all of this stuff here properly. And I do this with the tab key, which indents this by a few spaces. Of course, this just matters for organization. We can also keep this messed up if we want, but we probably shouldn't. Okay, so either type this out by hand or copy it, but this here in the back is just a note for myself. Because here, of course, you should use whatever ports you have set up in your Express app. If you followed my tutorial, this is port 5000 that we also entered in the env file earlier. And as you can see up here, this block defines what Nginx should do when we access a /API route, which are our backend routes. And you can Google what these different things here mean, but this basically points these API routes to our backend code, to our Express code. So when we access the root URL, we get to our React app, and when we access these API endpoints, we get to our Express backend. Okay, let's save this with Ctrl X, confirm with yes, and press enter. Then we type in sudo nginx-t. And if everything went successful, it should show the same text for you, or a similar text. Syntax is okay and test was successful. Then we have to restart Nginx with sudo service nginx restart so that these changes go into effect. And now we should be able to access our website without a port here. This port is blocked by the firewall, but Nginx now forwards this port to port 80, the HTTP port. So now this should work, and it does, as you can see. And when we remove the /API, which points to our backend, we should get to our React frontend. And there it is. Isn't that amazing? So now we should actually also be able to log in here with the credentials I've set up earlier. Wrong password. I think it's this one. Yeah, there it is. There are our nodes. And now the only thing left is to connect this to a real domain, right? Because we don't want to give around this IP address for people to use our website. And we also need an SSL certificate so that we get rid of this not secure warning, because this is not running under HTTPS right now, which it should. It's running under HTTP. So let's change this next. So to get a real URL, a real domain name, you have to spend some money, because those things are not free. They are sold, but they're usually really cheap. There are different websites where you can buy these domain names. A popular one is Namecheap, which I picked here for this example. And I've bought this URL, which I already told you earlier, codingandflow-sample.com. Now, how you connect the domain to your hosting will differ between different hosting providers, but the steps are usually similar. I will show you how it works for Namecheap. So here I have to click on Manage for this domain. And then when we click on Manage, we will get to this page here. We will get back to this in a moment. First of all, we go into our Linode backend here again. Then here in the sidebar, we click on Domains and on Create Domain. Here we type in the domain that we bought on Namecheap or wherever you bought your domain. So again, codingandflow-sample.com, we type it in without the W, without the www. Then we have to provide an email address where we can be reached for, I don't know, whatever reasons, any organizatorial stuff. I'm gonna use my Coding and Flow address here, info@codingandflow.com. And we also select insert default records from one of my Linodes. This will do some setup for us that we don't have to do manually. And here we select our server that we set up earlier. Then we click on create domain. And that's actually it for the Linode part. Now we also have to make a change to our Namecheap configuration to connect these two. For this we need these NS records here. So they are called ns1.linode.com, ns2, and so on. So we just copy the first one here. Go back into our Namecheap backend. And then we want to go here to name servers. And we select custom DNS. Then we add 3 more so that we have 5. For ns1linode.com, ns2, ns3, ns4 and ns5. Then we save this with this little checkmark save button here. Okay, and now our domain will be connected to our server. But this takes a while. This can take up to 48 hours actually. In a lot of cases it only takes a few minutes, but this depends. It's also faster in some countries than in others. So for example here in Germany the changes need a few hours, but when I use a VPN and access it through the US, then I can usually see the changes within a few minutes. What I will do in this course here, I will pause the recording for now and then continue when these changes are propagated and our website is available under this address. Okay, so I've actually waited 24 hours. You probably don't have to wait that long, but it was easier for me to record this way. And now my website is reachable under the URL I've registered, codingandflow-assemble.com. Now we haven't set up an SSL certificate yet, which means that the website will not be available under https:// and then the URL. So if you can't reach your website under your URL, make sure that there is no HTTPS in front of it. If there is, then change it to http://. This is also why this is showing not secure, because we need an HTTPS connection. Otherwise, it's not safe to send login credentials over the connection. And this is the next step we will do now. We will install an SSL certificate and we can get a free one from letsencrypt.org. It's absolutely free of cost and they have this little tool we can use called Certbot. So you want to go to this URL here, certbot.eff.org, and here are the installation instructions we have to follow to install this. So I've opened the PowerShell again, because I have restarted the PC. We of course have to log into our server, so let's do that. And the cool thing about the Certbot page here is that there are installation instructions for different combinations of software, like in our case Nginx as the server software, and the operating we are using on our server. In our case that's Debian. There is no 11, but I found that 10 works just as well. And if you use a different combination of operating system and server software, then you can just follow these instructions here. Of course, I will put a link to this into the gist as well. Okay, so you need command line, we have that, we have all the stuff they list here, we have SSH access, sudo privileges, perfect. So SSH into the server, we have already done this. Then we have to install this snapd, which is a kind of package manager. So here we have to select our operating system, Debian in my case, and then execute these commands. So sudo apt update, we have already run this at the beginning, so this shouldn't show any changes. Okay, one package can be upgraded, so it makes sense to run sudo apt upgrade as well. But you don't necessarily have to do this. The main purpose of update in this case is to get the latest version of snapd that we then want to install with this command here. So we paste this in as well, confirm this with a Y, wait until this is finished. Okay, then they are saying we should log out and back in or restart the system to make sure that snap paths are updated correctly. Just to make sure, I'm just gonna reboot the server, but it seems that logging out and back in again will work as well. I wait until the server is restarted so I can get back in. Okay, so I've SSH'd back into the server and now we wanna run this command. Sudo snap install core. Run this as well, wait until this is finished, and then we can go back to these instructions here. Okay, so they want us to run install core, which we've already done, and then also refresh core afterwards. Let's run this as well. And now we should have the latest version of Snapd. This command should not be necessary because I haven't installed any Certbot before, but we want to do so now. So we copy this command, execute it as well. Then there is another command we have to execute. So copy paste this, but we are almost done. This doesn't show any confirmation, but this should have succeeded. And then we run this, and as you can see, this also sets up Nginx automatically, so that this works together well, because this is the selection we did above. So we run this command. They want an email address from us. I think this is for messages like when our certificate is about to expire. I'm going to use my business email address, info@codinginflow.com. Terms and conditions, we confirm this. Willing to share our data, we don't have to do this, so I'm going to type in no. Which names would you like to activate HTTPS for? And then it shows us these two URLs which we earlier set up in the Nginx configuration file, if you remember. We want to set it up for both. So we type in 1, 2, which selects both 1 and 2. Then we wait until this is finished. And if everything went successful, it should look like this somewhat. Then the last step is to test automatic renewal to make sure that this works as well. As you can see, it takes care of automatically updating the certificate from time to time. I think every 3 months or so. But we have to check if this actually works, which we can do with this try run command. Then it should say congratulations, all simulated renewals succeeded, and then SSL is set up. To confirm that this worked, we can go back to our website. And now we should be able to append https:// in front of it and still reach it. And now, as you can see from this log, SSL is activated, the connection is secure, and our website works, and other people can use it. Can navigate between different pages, can log out, we can sign up, and so on. So yeah, this is how you deploy and secure your website properly and how you connect it to a real domain name. Remember that you can check out the full MERN tutorial on my channel where we learn how to build this app here. And then I hope this was helpful. I wish you a nice rest of the day. Happy coding. Take care.